Okay, our next graph is also a real-life graph, but now instead of distance time, we have velocity and time. Velocity is a really fancy word for speed. So I'm just going to write that in. So that's telling us what the speed of this ball bearing is after a certain amount of time. So the graph shows us the first 20 seconds. The first thing we want to figure out is what the acceleration was in the first 5 seconds. So from 0 to 5, what is that acceleration? Now, on a speed time graph, acceleration is the same thing as saying finding the slope. So if we want to find the slope of our graph, that is something we hopefully know how to do. But as soon as you see the word acceleration, just think slope. So to find the slope of any graph, what we're going to do is m equals rise over run. Or we're looking at what's changing in our y's and what's changing in our x's and putting them over each other. So looking on this graph here, I can draw a rate triangle from 0 to 5 seconds. So from 0 to 5, the distance or the run here, that's going to be 5. And to get from here to here, we are going up by 1 meter. So my rise is going to be 1 because we're going up by 1 meter. And our run is going to be 5 because we are going across by 5 seconds. Now I can leave it as 1/5. I would take that as an answer, but for the sake of having a decimal, it is an application question, I'm going to write that as a decimal. 1 divided by 5, that's going to give me 0.2. And then in terms of units, I'm going to put meters per second squared. So acceleration is just like speed with a little square on whatever the time is. The second question says, how long is the ramp? So we look at our graph here. We look at our ball increasing in speed, increasing, accelerating, and then it stops accelerating and it just sort of keeps rolling at the same speed away. What that says to me is it's increasing as it falls down the ramp, but as soon as it hits the bottom of the ramp, it's going to stay the same speed as the acceleration it picked up. So this point is probably where the ramp ends. To find the distance, we're not going to look at the time, we're going to look at the velocity thing here. So our speed says we're rolling at roughly 1 meter per second. And we are rolling 1 meter per second by the end here over 5 seconds.